Well, welcome back. Hope you're all doing well. Hope everyone was happy with their assignment 1 marks. If you've got any issues about those, then please don't hesitate to drop us an email, give us a telephone call. More than happy to discuss anything with you. So today we're going to have a quick look at line of balance. We've done networks, etc. I've put some very good YouTube videos of other people explaining line of balance, so there's several different ways it's being explained, so there must be one that suits you. I'm going to give a bit of an overview on them at the moment. So line of balance, you normally just call it LOB. What is it? It's a simple diagram. This is a graphical presentation, rather like a Gantt chart. Almost looks like a diagram, but it's a simple diagram to show location against time. So about the time where a certain activity or crew or gang of men will be working on a given operation. So it tells you the location where the plaster is going to be and how long they're going to be and what times. It focuses on balancing the time, slightly different from what we looked at previously, trying to find critical paths. This focuses on balancing the time taken for individual activities, and it can either redistribute the resources or reduce process waste. So you can balance if you're building something. Obviously your electricians can't go in until the floors are in, the walls are there, and then your plasters can't go in until they're done, then the decorators can't go. So it manages to balance them all together. So line of balance, very basically, and hopefully you've looked at the other videos. They're not that long particularly. Textbook's got it as well, but line of balance is a methodology, as the others were methodologies, to optimize resources. So they're not hanging around and there's not too many delays and they're not getting in each other's ways. The line of balance, it's a visual tool. It's a graph. You'll see it in a second. Let's let you see if the construction program that's been set out can actually be achieved with the minimum delays, minimum wait periods, sometimes called lags or buffers, and without any clashes taking part. Because if you end up with workmen turning up to do their work and someone else is in the way, you've got a clash. It is primarily, it's basically used on anything that's got repeated elements, sort of like a linear process. Obviously highways, pipelines are the same. So once you've done the first kilometre of highway, the second, third, fourth and fifth are identical. Now you might as well just keep repeating as you go. Using critical paths and Gantt charts would be messy. You'll see this is a nice simple way of doing it. If you think about it, a high-rise building, or maybe the refurbishment or construction of hotel rooms, is repetitive as well, except they're going vertical, not horizontal. But it's the same thing. Once you've done the first floor of the building, you repeat all those particular functions and trades is repeated for the second floor, the third, the fourth, the fifth to the top. It can work for bridges as well. What are the benefits of this? Another methodology for us to learn and use. And line of balance does get used, whereas some of the other ones I said I'd never really seen them being used in practice. There's continuous resource use, making sure there's no downtimes and waiting times. You minimise the starts and stops between trades. Your gangs, crews, subcontractors, they'll spend less time and less money on the later units once they develop a learning momentum. They just get quicker with familiarity as they go, and they produce best practice ways of undertaking the work because it's repetitive. Generally it's believed that doing this you can improve your productivity by up to 20%, and that's not to be sniffed at when you start thinking of the costs involved. And it saves money and time, and that's what project management's all about anyway, trying to save money and be on time, save time, increase profit. And it's a lot faster process to do than populating a Gantt chart, although on any reasonable project you'll still have a Gantt chart for different reasons. to manage your resources and the cost flows, cash flows. And it just gives you visual control. Even people who don't understand it can see what it means when you just give them a 2-minute introduction to it. It's a nice fast way of doing it, nice blend, but you haven't got hundreds of tasks, so you've got less tasks to deal with. You've got less links. It's faster to create one. It takes a lot less time to understand it, to interpret it. You can do what-if scenarios really quite simply for this. And these things can be done on software, by the way. So what's the difference between the activity-based, which we've already looked at, versus the location-based, which is line of balance? One's based on many activities and the other's based on the locations of where the activities take place. Obviously a location, say the floor of a building, is almost, say you're talking about just the floor of the building, it's one. There's only one location, but that might contain 100 activities. So in an activity-based one, you'll have 100 of them. In a line of balance, you'll have one. Activity-based, we did it previously. So an example, we're building a 30-floor high-rise building. There's 4 activities in each location, the location being a floor, means we've got 120 activities. One of those activities is formwork reinforcement pouring on the same floor, and it's got 60 links in it, so it's reliant on or predecessor to 60 things. Pouring and formwork the next floor has got 29 links. We've probably lost links from the initial establishment of the site and getting the initial equipment in place, because it's already there for the next floor. Finishes 2 floors below, so 28 links. Internal links in finishes to prevent resource overlapping, you've got another 29 links to stop the overlap. So we've got 120 critical paths, activities, and 266 links. So that's quite a complicated one, and we only did a really simple one for assignment 1. If we use the line of balance, which is reliant on location, you've got 4 tasks at every location. Remember, the location is the floor here. You've got 4 links between those activities, because there's only 4 of them. You've got 4 links inside activities. Total 4 tasks and 8 links to do the building. Much, much simpler than the one above. So activity based would look something like this. So you formwork floor 1. Where are we? So you can formwork floor 1, reinforcement down, pour the concrete, nip up the next floor, formwork reinforcement concrete, 3rd floor, round you come. And then this is the finishing, this is the screeding over the top of it, because it's all set, and this is much faster to do. So do floor 1, 2, 3. This screeding, this is a trade that would catch up very quickly with the slower trade in front of it. And this is what we're going to try and look at. I just want to introduce you to the basic table for a line of balance that we would fill out, so we could go and plot the chart. I'd guide you back to a couple of the video links to the YouTube lectures, because they go into this in a lot more detail for you, and you can watch it again and again. We have 9 columns. Now, column number 1 is the activity. We go A, B, C. You can go as far as you want. So that could be formwork, reinforcement, pouring concrete, floor finish. Could be, or whatever you're doing. You need to know the man hours per unit, per floor. Think back to that high-rise thing. So that normally is given to us by the estimator, because they've worked this out previously. That's how they came up with their tender cost. So they will tell you what this is. How many men do they think is going to be in a gang, in a subcontractor's team? Again, you can have a fairly good estimate of that. The estimators might know, or subcontractors might know, or from previous historical information which we've used previously, remember. Then we need to find out what the theoretical gang size at the output we've got here in column 2. What is this theoretical gang size? Well, this rate, sorry, and it's called G. Well, G is quite simple. So if we come down column 4, if we come down here to column 4, you come along, and the number to go in column 4, which is called G, So that's what we're going to enter, is R, and that's given to you by the estimators. That's this one here. So R times the man hours per unit, which is column 2, divided by the number of working hours per man per week. He might be doing a 40-hour week. Divide those and you get G, and G goes into column 4. Column 5, that's the theoretical size. What's the actual gang size going to be? And that's called GA for the actual. So that's column 5. So here's column 5. It's a calculation. So the actual gang size is what we're trying to find, GA. GA is a multiple of column 4, which is the theoretical size, G, and the actual rate of output, which is RA, which we're going to get here. So column 6, RA, the actual output rate, is equal to the output rate, which they told us over here, times the actual gang size, which your subcontractor would have said, I'm bringing 4 men on site, I'm bringing 10 men on site, I'm bringing 1. So that number is there. That's the reality of it. We know what theoretically it should be, but that's what they're actually going to bring. So what's really going to come, divided by what we theoretically think it should be, times the theoretical rate of the work being undertaken, which your estimators gave you, will give you here the actual output. See, R is given to you by the estimators. So we work out it's actually column 6 is going to go here. Column 6, we're given that. We just worked it out. Column 7, now this is where we get to the bits we're really interested in now. Activity duration for 1 unit, which on the example previously would be 1 floor, casting that 1 floor. So D is the duration, column 7, so the duration is equal to the man hours per unit, which is column 2, it's here, divided by the number of men in a gang times the number of working hours per man per day. You might be doing an 8-hour day, and there might be 4 men, 32, so man hours per unit, which we've been given. Divide the 2 and you get the duration. Great, that's good. What about column 8? Time from the start of the first unit to the start on the last unit. So that's the start on the ground floor, shall we say, to the start on the 30th floor. Well, we go down here. This is a little bit complicated, so it's T for time, obviously, and it's equal to N. Now, N is the total number of repetitive units or locations, sections, i.e. it's the number of floors in this instant. It could be the number of kilometres on a road or a pipeline, but on our previous one, it's the number of floors, which is 30. So it's the number of floors, 30, minus 1, so 29, times the number of working days per week, which could be 5 or 6, divided by the actual output rate. And that will give you the time it takes. Column 9, the minimum buffer, this is your lags or your delays, which often you can't avoid. They're normally given to you by the estimators because they've included that sort of thing when they were producing the price. Now, it seems funny to fill out. This can be computerized very quickly on Excel. And the graph that we get, well, we use a very simple graph such as this. So along the bottom there is time. Now that could be, depending what type of work it is, could be hours, days, weeks. You're normally in days for most work, unless you're doing something like something massive, when you might want to do it in weeks. So that's the time. So it starts at 0 when we first walk on site, basically, and then it works its way along till we finish. Vertically, though, we've got the location of the activity, and that could be, if you're talking of roads or pipelines, it could be the linear meters. You could be at 1,000 linear meters, then 2,000 linear meters. That's progress, and it's going up. It could be square meters if you're casting a car park or something, or a floor. It could be just the number of floors, as we've got in our example. It could be kilometres if you're doing something really long. It could just be the number of things you're doing. You may be putting in lights, or smoke detectors, or windows. It's just the number of them. And it goes on. So you can choose loads of things. But that's all right. So we've got a graph. Fantastic. What do we do with it? Well, we start plotting the tasks. Now, obviously, task A starts, shall we say that's week 1. It starts at week 1, and it doesn't finish until, I don't know, say week 5, we're going to guess. So week 1 to week 5, which means it's a 4-week duration, which came off that table we calculated. So we know the duration of it, and we know the location we're going to be at. So we're going to be at floor 1, floor 2, floor 3, floor 5, floor 6, and that'll be floor 30. Well, that's nice. So it's lovely to work on your own with no one else, but then you've got another task running along with it. Now, obviously, this has taken 4 weeks. This task could be the screeding. It's so much faster. So the steeper the line, the more production you're getting, the quicker it's running. And the shallower the line, the slower or the less productive the task is. And it's a matter of balancing them all. So as you can see, this one has been going exactly the same locations, obviously apply, same graph. This one's starting, if that was week 5, that's probably starting at week 4. And it's going floor 1, 2, 3, 4, 5, it's going very quickly. Now you could try to start this a bit earlier, but you would clash. They would cross there and you can't do it. Where they touch is where they're both in the same place at the same time. And if the blue one goes slightly past, goes shooting off here, well, there's no point because they'll be trying to screed a floor that doesn't exist because it hasn't been built yet. A slightly more complicated one, we've got formwork reinforcement pouring the concrete. I like that simple one to start with, and this is the finishing. See, it's steeper. So false work reinforcement and concrete pouring all at the same speed because they are intricately connected. None of those can go quicker than each other. And what you see here is what we tend to, that was just a simple line diagram before, but here you can see we've actually got the duration of the formwork. So the duration takes a week. And this is for a level. So that's a week. And then you've got probably a bit less than a week for reinforcement, and the point of concrete might be a couple of days. Then you move on to the second level. See, that is repeated identically. Then you move to the third level, identical, again. With your floor finish, it's only 1. There's no more than, there's no other activity. It's with single activity. They do it, next floor, next floor. But notice they're catching up, and they would overtake up here, which can't be done. If you think we represent it as a line diagram, in reality, it's chunks. So this one's steep enough so that if you took that as a chunk of time, that's a week to finish, so that would all be filled in. Then this one would then be filled in, then this one would be filled in. The line is the average. This one obviously done, so that we'd fill that one into there, then there. It's accidental that they don't overlap on either of these. They can overlap, so you can get a staircase effect. Superior project control. So as you notice, it's only a graph, so it's easy to interpret. It's an uncomplicated display. You can see if those lines clash, or maybe you've got the opposite that I showed you. So the first trades are quite quick and the last trade's quite slow. Then you might decide to start the first trade a bit closer to the beginning of the contract period, as long as you don't get a wrong clash. It's very simple to manage. It's very, very easy to monitor because you're monitoring a floor, not all the individual trades or activities. It's easy. Progress updates are real simple with this. It's effective control. You don't need to be a specialist to understand it. There are some calculations that come along with it, which we did look at quickly a couple of slides ago. The object is to get a resource balanced schedule. So you've got to work out the size of the right crew, gang, subcontractor, whatever you want to call them. that are going to work on each of these repetitive activities, and we showed you how to work those out. So the units are delivered, they've got a rate to meet a pre-specified deadline. We've done the critical path network, so we've identified them, and they work is continually maintained. They don't stop and start. Sorry. The analysis determines the start and finish times for every activity and the units that they're going to be assigned. Now, remember the activities, but we're actually converting those into locations. We've got 3 diagrams that are common. There's the production diagram, and that shows the relationship of the activities for a single unit, for a single floor in our example. So you'd have the 3, and we looked at that a little bit ago. There's the objective diagram, used to plot the planned or the actual number of units against time, so we can see if we're on time. And the progress shows the number of units, the activities completed. Very useful if you're putting your payment claims in. Didn't quite get caught out here. Drawing a schedule, so similar rates are parallel lines, different rates, the lines are not parallel, so they've got different angles, different steepnesses. Conflict points are where they cross each other, the touch. Let's get around here. So we have one here, so here we go. So it's got an angle of R, and you can work out what R is here by the number of units minus 1 divided by TF minus TO. Let me find out what that is, because I can't remember, but it's the same calculation as earlier on. We do try to synchronize the crews. Oh dear, I've got an American spelling. We can calculate the resources that are needed, and we can do a schedule. As I said earlier, there's probably a Gantt chart or similar running in the background for other purposes. Here we have different crews trying to synchronize them. They could be doing different activities. Now you've got crew 1, and then you've got crew 2, then you've got crew 3. Their durations, they are parallel, obviously. So if we were to represent that just on a line diagram, it would just be a line up the center. Now it's a simple relationship between duration, and we're using the number of units here, the location, we should refer to them, and it's a repetitive activity. The slope of the shaded triangle, you can work the slope out, basic trigonometry used. Calculating resource needs. Now this is very well explained in one of those videos below in the Moodle Week 7 tab. So I'm not going to go into detail of it. We know what that is because we did one last week. We did this last week. We were just doing numbers of crews. We know how many units we've got, or how many, maybe that could be 61 rooms in a hotel. We've drawn the line of balance at month 16. Just to reiterate what we just looked at the other side, but we've filled it in on here now. And then when you put it on a graph, it can look quite messy. We've got a problem there. We cannot clash. You can't do that. E is, it's a very slow process, E is. B is extremely quick. So if you look here, B starts at week 6 and it finishes at week 18. This one starts at week 3, finishes at 23. So these all done, so they show you what the answers are to the calculations. We've included a buffer as well. A progress diagram and an objective diagram. Don't tend to use that one very often. Progress, you can quite often just use one and you don't have to design the others all the time. I'm not even going to describe the process one to you because it's not particularly useful. It's a bar chart basically, look. Remember this axis here is locations or numbers of things. This is time. Oh, we've come to the end of it. That caught me out somewhat. I didn't realise that. Please look at the videos below and read the textbook because they're probably more helpful than me sometimes. I would talk to you about another methodology called Prince 2, but if I've got time at the end, I'll do a little lecture on Prince 2. That I'm qualified in that one. Good luck with the assignment. The assignments I saw were good. If you put the same level of effort in, that'd be a good idea. Any problems, just go on the Q&A and ask a question. I may see you tonight for the tutorial, but you don't seem to need to use the tutorial so far. You're quite self-sufficient, and looking at the quality of the work, I'm not worried if you're self-sufficient. I would panic if there was anything else. So thank you very much. See you for the tutorial.